Okay, good morning, everybody, and welcome to the first webinar we have on HIPWE for the 2025 hurricane season. My name is Zach White. I work for the Actuarial Prices and Filing Division for RMA out of Kansas City, and it is still cold here. We're looking at piles of snow on the ground from a snowstorm. I wouldn't mind knowing where other people are from. So if you wouldn't mind dropping in the chat where you're located, you could do state or county, but just to kind of get a sense of where people are attending this webinar from. I've been involved with HIPWE since the inception, and hopefully today we can answer some questions and prepare you to be able to make the best insurance choices for your operation. So with that, we do have an option for a question and answer session at the end of this. So if you wouldn't mind, as questions come up, just putting them in the questions and answer section above. If you type that in there at the end of the webinar, we will answer those one by one. I'm going to turn my camera off now, so the screen will be a little bit bigger. Okay, so just a little background for hurricane and tropical storm. The hurricane program came at the direction of the 2018 Farm Bill. We started working on that immediately and began offering HIPWE in 2020, which is a good thing because in 2020 we had 7 hurricanes. It must be, some of the principles are HIPWE must be elected in addition to your underlying policy. It's an endorsement. Hurricanes must be a named storm named by NOAA. A tropical storm option was then offered in 2023, which again was a good thing because we had 6 hurricanes and tropical storms in 2023 and 2024. To be able to have the tropical storm option, you must have HIPWE as well. And all of this must be selected by the sales closing date. Upcoming sales closing dates that we have are January 31st, February 28th, March 15th, April 15th, May 1st, and May 15th. So a little bit about the program structure. As I said, HIPWE is an endorsement that adds specific coverage only for hurricanes and now tropical storms to an underlying NPCI policy. It covers the deductible portion of the policy up to 95% of the crop value. And I have a little graphic that'll help explain that a little bit later. The coverage percentage can be elected from 1 to 100%, which allows you to tailor the coverage to your individual operation. A hurricane must have sustained surface winds of 64 knots, which is 74 miles an hour or greater, according to NOAA. And we'll talk a little bit about the data later also. HIPWE payments are 100% of the liability. Now looking on to the tropical storm option, we changed the county loss trigger to add tropical storms. However, in this case, tropical storms only pay out 50% of the liability. You can have multiple tropical storms or hurricanes, but under no situation will the liability ever exceed, the payments ever exceed 100% of the liability. A tropical storm trigger is 2 parts, sustained winds of 34 knots or greater, and I think that's 38 miles per hour. And in addition, you must receive 6 inches of rain, which we have amended to 5.9 inches of rain starting in 2025. And that 6 inches of rain has to come over a 4-day period. 1 day prior to the tropical storm, the day of the tropical storm, and 2 days after. The tropical storm option, or it is an option on the HIPWE endorsement, and we expanded the hurricane and tropical storm area when we implemented the option because there's more susceptibility inland for tropical storms to extend. A little bit about the data for the program. All of the weather information is provided by NOAA. The wind speed information is provided by the International Best Tracks Archive, abbreviated IBTracks. And the precipitation is from the Climate Prediction Center. And we've used the Climate Prediction Center on several other programs. If you think of PRF or annual forage or apiculture, or even our new shellfish program, CPC has been the agency that has provided our precipitation information. We also use census data to give us the county shape file, and then also what counties are adjacent to one another. We have made some slight modifications to the adjacency file to account for counties that are very close to touching, but aren't quite when you zoom in really, really far. Some of our criteria that we had for selecting the data that we were going to use is, one, it must be publicly available information. We don't use any private data in the administration of this. That way it's not subject to any potential manipulation. The data has to be consistent, reliable, and the weather information that we have goes back several decades. As I said earlier, we expanded when we introduced the tropical storm option. The green counties are the current HIPWE and tropical storm counties. The orange counties are the counties that we expanded to. And then the only other color on the map is Hawaii, and we have not expanded tropical storm to Hawaii yet, but it does have HIPWE. Okay, so I mentioned earlier, this is a typical example of somebody who has an underlying MPCI policy of 65%. So in this fictitious example, let's say that there's $100 worth of total liability. $65 would be covered by your MPCI policy. $30, the difference between 95% and 65%, $30 would be eligible for HIPWE coverage. And then the $5 is your true deductible. So what happens if you have a hurricane, a tropical storm, or both? In that prior scenario where $30 was your HIPWE or tropical storm liability, if you had a hurricane, that pays out 100% of the liability, which would, in this example, be $30. If you had a tropical storm only, your indemnity would be the $15 or 50%. If you had both a tropical storm first and then a hurricane, your total indemnity would be $30. You would get $15 for the first tropical storm, and then the remainder for the hurricane. If you had a tropical storm, and then a hurricane, your indemnity would be $30. You'd get $15 for the first tropical storm, $15 for the second, but since you'd already been paid your full indemnity, you would get $0 for hurricane. And then the last example is very similar, where you have two tropical storms, you would get the $30 maximum indemnity payment. Just to reiterate again, you will never receive more than that $30, your total liability, regardless of the number of storms that you have. So a little bit about the details, and this might be a little much, but I do think it's important to discuss. So I want to talk about how we calculate the wind corridor, the wind extents, and how we develop the location, the counties that are actually triggered by the wind speeds for hurricane and tropical storm. The table that's at the bottom left is the actual data that we get from IBTracks, the center, the agency that provides us the wind information. So you can see the season, the name of the hurricane, the 3-hour intervals of time where they give us a precise center point, and then the wind extents. You can see the latitude, the longitude, the Saffir-Simpson hurricane scale is that next column where there's ones and zeros. USA wind is the wind speed in knots. So you can see anything above 64 knots has a Saffir-Simpson wind scale of 1. Then the last 4 columns are the extent of the 64 knot winds in each of the 4 intercardinal directions: northeast, southeast, southwest, and northwest. So basically at each 3-hour interval, we take the latitude and the longitude, and those are represented by the red X's on the image. And then we take the 4 intercardinal directions and we take the maximum extent. So if in that first, actually in the second row, the northeast quadrant, it extends 15 nautical miles out. And there are no other quadrants that have those extents. We would take the maximum there. So the maximum extent for that 3-hour point would be 15. For the next row down, there's a 25, a 15, a null value, and then a 20. So we would take the 25 in that instance. So for each of those maximum values, we would draw a circle around the center point in the maximum direction, the maximum length. And we do that for each of those center points. Now, in this image here, there is a hurricane transitioning into a tropical storm. So we estimate, interpolate where that final hurricane center point would be, and it's a straight interpolation. So basically, we take the distance between the 2 points, and as you can see there, we divide it up evenly between the wind speed of the hurricane. And as you can see there, the last hurricane point is 70 knots. The first tropical storm point is 60 knots. And we divide that line up evenly and put a center point at 64 knots. We also do a similar estimation there for the wind extents. And in this situation, we would do a standard interpolation with a minimum value of 5 nautical miles. And so that's how we get the center point of the hurricane. That's how we get the wind extents. And then we take those series of circles and we draw, one way to explain it would be to take 2 Frisbees and snap a rubber band around it. Another analogy would be a bicycle chain, but we take each of those circles and we draw what's called a convex hole, and that's a mathematical term, but we basically take 2 circles that are next to each other and we do that bicycle chain analogy to where we put a convex hole around the 2 adjacent circles. So if you're looking at the last 2 hurricane points, you can see that pink line there, that pink shape there, that's a convex hole that's snapped around the 2 last hurricane points. We do that for each of the successive hurricane points, and that's how we get our hurricane or tropical storm corridor. The next thing is how we determine the precipitation amounts for each county. So the data that is provided to us by NOAA CPC is gridded precipitation data. So the United States is parceled out into quarter-degree latitude by quarter-degree longitude grids. That's about, on average, about a 17-mile by 17-mile area. They use weather stations in and surrounding the grid to determine how much precipitation fell inside of that grid. We take those gridded values and do a straight weighted average for what percentage each grid makes up of the county. So for example, Seminole County here, the grid that's in the southeast portion takes up 38% of Seminole County's area. In the table to the right, it rained 8 inches in that grid. And so we get a weighted average of 3.04 inches for that grid. We do that for all of the remaining grids, and we sum that up to determine what the weighted average gridded precipitation is for Seminole County. And this example will be, how do we determine adjacency? And so this looks like a lot here, but I will try to explain it. Looking at this image, the counties that experienced direct hurricane force winds are the dark green, and they're labeled HU for hurricane. The light green, so those would be directly triggered for a HIPWE payment, the full payment for $30. We also allow for any county that's adjacent to the hurricane direct triggers to also receive payment for HIPWE. So all of the light green counties trigger a HIPWE payment also. The counties that show TS on them experienced direct tropical storm force winds. But you also have to have the rainfall requirement to receive a payment. And so I'll walk through each of these examples. For county number 1, the red line pointing to county number 1, that was an indirect HIPWE trigger. So it got paid the full amount with the full $30 under the policy, but it also met the wind requirements for a tropical storm and got the 6 inches of rain. So it triggers the 3 counties that are adjacent to it to the east. Trigger number 2, this is a direct tropical storm trigger. So the other one was a direct hit or an indirect HIPWE trigger. This one received the tropical storm force winds and also the rainfall amount. So it triggers itself as a direct tropical storm trigger. That's the dark blue, but it also triggers the 4 counties to the northwest of it, even the 2 counties that didn't have the tropical storm force winds. County number 3, it received 6 inches of rain, but it did not receive the tropical storm force winds. It will not trigger its adjacent counties, but it did trigger because of county number 2, so it will receive the full TS payment of $50, or I'm sorry, 50% or $15 in our example. The last one here is county number 4. It got the 6 inches of rain, but it did not meet the tropical storm requirement, so it does not trigger, nor does it trigger any of its adjacent counties. A general timeline for how this whole program works is once a tropical storm or a hurricane event occurs, within about 2 to 3 weeks, RMA is going to download and analyze both the wind extent and the precipitation data to publish the triggers for the hurricane for both HIPWE and tropical storm. Within about 2 to 3 months, the Climate Prediction Center reviews their data, does a quality control process, and we will take that data, reanalyze it, and publish any new counties that trigger under a tropical storm. In the spring of the following year, the National Hurricane Center and IBTRACS will do a review of the entire hurricane season. They take additional weather stations, additional weather reports, and try to finalize the data for the entire year. RMA will take that data and analyze it according to our methodology, as I've gone through here, to determine if any other HIPWE triggers are met. One thing to note is that if new counties are triggered based on the quality control data, we will add those triggers. But if the quality control data comes back and shows that a county that we had already previously published as triggered, we will not take that away. So we will add counties, but we will not take any counties away. A few common misconceptions that we have within the program that we're trying to dispel is that the first one is 6 inches of rain at any rain gauge in the county. That does not mean that the county average was 6 inches. There's a lot of times where we will get questions about weather stations that, this weather station had 10 inches of rain, and so the county should trigger. Well, there's other weather stations that are in the county that showed only an inch of rain. Well, if you were to take that 10 inches of rain from one gauge and the 1 inch from the other gauge and you average it out, you may not meet that 6 inch or now 5.9 inch threshold. Another common misconception is that there's damages to my farm, there's trees that are blown over, there's flooded areas on my farm, and since I've had damages on my farm, that I should receive a payment. But it's not that simple. To receive a payment, you have to have the wind, you have to meet the wind threshold and the precipitation threshold. Wind threshold only for HIPWE, wind and rain for tropical storm. Damages on your farm will be covered under the MPCI policy. Another common misconception is that we use every rain gauge that is in the county, and that's not true. We only use, we only use the data provided to us by the Climate Prediction Center. RMA is not looking at individual weather gauges and making determinations based on that. We only look at the Climate Prediction Center data. In talking with the Climate Prediction Center, they only use weather stations that are approved by the NOAA's Office of Observation. And those weather stations give them a very long history that allows us to set appropriate premium rates to be able to charge premium for this program. And the final misconception here is there's often weather reports from a local weather station, and they're discussing, the highest wind gusts. And wind gust, the definition of a hurricane is not based on wind gust, it's based on sustained winds. And there's even a more detailed definition of what sustained winds, but the point here is that wind gusts do not necessarily equal sustained winds. And then that's the last part of my presentation. Again, if you have any questions, please feel free to put them into the Q&A portion, and then I'll be happy to answer those now.
We have 2 questions currently, and please put in more questions if you have any. But question number 1 comes from Melissa. She asks, how do you define day of tropical storm for a location and area?
Okay, and that's a good question, and I'm going to come back up to a slide here. So as you can see in the table in the bottom left, you can see in this fictitious example, for each one of these center points, there is a time associated with that. And with that time and center point, we can draw this circle, and then the convex holes that I talked about. Whenever the convex hole, whenever this wind corridor intersects your county, and that time, that is like ground zero. We will, if it happens at September 29th at 6:00 p.m., we use the 28th, the 29th, the 30th, and the 31st. Well, in September, there is no 31st, so we'd use October 1st. But that is how we define the day that the tropical storm enters your county.
Thank you, Zach. The second question we have is, do we have an idea of how many weather stations there are per grid that collect rainfall data?
So to answer this, each grid is different. As you know, there are some areas in the county where they're very populous, and there's lots of grids. They're often located at airports and things like that. So each individual grid is different. I wish I could remember off the top of my head. I think there are either 7,000 stations or 7,000 grids. But there is on average about one station per grid, and that's not an exact number, but on average about one. But each individual grid is different, and so I do know that Climate Prediction Center uses between 4 and 10 weather stations to determine the amount of precipitation for each grid. So there may be grids that have 1 or 2 weather stations, and then they would then use a few more weather stations surrounding the grid to determine that. And there may be some grids where there isn't a weather station present, and they would use weather stations from surrounding grids.
No other questions at this time. I guess we'll just wait here for a few minutes, and if there are any more questions, we'll answer them. But if not, thank you for joining us.
And I'm happy to answer any follow-up questions, Melissa and Kevin, if I didn't do a very good job of answering yours the first time.
New question. Can you explain the averaging with rainfall again?
Sure, let me get to that slide. So here in Seminole County, we actually have 5 grids, and maybe I didn't pick the perfect one here. I thought it was pretty good, but there's a grid in the very southeast corner that makes up less than 1% of the area. But for the majority of Seminole County, it's covered by 4 different grids. And each one of these grids, depending on the amount of the county that they make up, they will be weighted based on that percentage. So for example, starting in the Northwest, that grid makes up 19% of Seminole County. The grid extends further to the north and further to the west. The grid that makes up 14% also extends for this. These are kind of trimmed at the county line, but that grid makes up 14% of the grid. The grid to the south and west makes up 29%, and the grid to the south and east makes up 38%. So you can see in the table there, each one of those grids, we take the percent area and we multiply that by the rainfall for those 4 days, the day before, the day of, and 2 days after. For the one that rained, or that the 19% area, it rained 5.5 inches in that grid over that 4-day window. So we multiply 19% times 5.5 inches, and we get 1.045 inches of rain in that grid that will be attributed to the county. For the one that's 14%, we take the same calculation. We multiply 14% times 6.5 inches, and 1 inch, almost 1 inch, 0.91 inches will be attributed to the county from that grid. We do that for all of the remaining grids, and then we take the sum of those. So we add up the 1.045, the 0.91, and on down the line to get the 6.16 inches of rain.
Awesome. Another question that I had was, can I have contact information? I will provide contact information for regional offices. You can reach out to your local regional offices if you have questions about the program. But Zach, do you mind providing yours as well, or should I just?
No, I think my contact information might be on the main HIPWE page, but it might not be. But I am always available to answer questions. So you can provide my contact information to anybody on the call.
Is there a way to determine how many grids with their percentages cover a county? Or is there a table that RMA is allowed to share?
Yes, I don't think we have that information publicly available. But for each storm that occurs, we uh, develop a spreadsheet that has all of the grids and the percent of the area that each grid makes up of the county, the rainfall that occurred, and then the weighted average rainfall. So this is something that we do for each individual storm. And as questions come up, we can provide that information. But it's not something that we publish at the beginning of the year. Surprisingly enough, counties do change. I think it was just last year or the year before, Connecticut changed all of their counties for their entire state. There wasn't a single county that stayed the same. And so there are changes that happen, throughout the nation that it would be it would kind of be problematic for us to put something out there. I don't monitor the census information, daily, but we want to make sure that we have something. I don't want to put something on our website that is incorrect. And so at the beginning of each year, we use the Census Bureau at that time that is available. And then we use that for the entire year. But to answer your question specifically, you can ask that and we can provide that information to you if you have any questions in particular that you would like to know the grids and the percentages.
Follow-up question. If there are multiple gauges in the 38% grid, is the 8 inches a total from all grids?
So the 8 inches, so this grid will extend, it's bigger than what you see in Seminole County. It extends into the county that's immediately to the east and also immediately to the south. But it does that grid makes up 38% of Seminole County. Now, NOAA CPC in this example has told us that it rained 8 inches. The gridded average precipitation was 8 inches for that particular grid. If there are multiple gauges in that grid, it would have been an average, an interpolated average of all the weather stations and in that grid or surrounding that grid. But it would have been the weighted average of all of the gauges that are in that grid. So the 8 inches isn't a total from all grids. It's the 8 inches for that grid.
I'm not seeing any other questions. We will also have the exact same presentation on February 13th if you or your colleagues weren't able to attend today, and you just want to follow up with some more questions, please join us February 13th. I'm not seeing any other questions here. Okay, I think we'll call it the end of the presentation. Thank you all for joining us. And again, February 13th is another opportunity for you to listen to this presentation and ask questions if you have any. Thank you, Zach.
Thank you.